Okay guys, this goes along with page 80 that I left for you guys to do today. And we're number 10. They ask you to do a transformation of f of x equals x cubed as a parent function for 4 different graphs that show. So there are 4 parts of this question. You'll need to be able to reference your textbook, page 80, in order to be able to do this problem. So if you're not there, I would pause it and get there really quick. Now that we are all on the same page though, we can look at it, and I'm looking at that one. On number 10, it's certainly a little bit different than the parent function on part A. It looks like this. So it's flipped from what it was in the parent function. And it also looks like it's been moved up, and I'd say that that point, really terrible looking graph, is at 0, 1. So we have our graph. That's what it looks like. Because it's been flipped, I know I'm going to have a couple of things. And if my parent function was x cubed, which it is, I'm going to have this function right here, which they ask us to do. I just said the transformation of it, so I'm going to call it g of x, I guess, because it's something different than what they've already called the parent function. In order to move a function up 1, we're going to do plus 1 at the end. I know that's going to happen. Before that, though, I need to be able to reflect this. It's not moved left or right at all, it's still at 0, but it did go up 1, and in order to reflect this thing, we're going to have a negative right there for negative x cubed. There's our new function. For B, we are going to be looking at that, and it looks like it's over and has a center at 1, 1. So in that case, they want to move things to 1, 1. Then what we have to do when we write the function is going to say, well, in order to move it to the right one, we have to, in parentheses, subtract 1. That's going to tell us that we have that transformation or translation to the right 1 unit. It was cubed, stays cubed. And then finally to go up 1, we do that, just like on the last problem. That one we didn't have to do the negative because of the shape of the graph. It was like this, just like it was with the parent function. When we go to C, you're going to look at it, and it's a little bit further over there on C. It has been flipped because the graph is basically really terrible version of the graph. Looks like this. So it starts high, ends low. That means it's going to be reflected, and I know that I'm going to have g of x equals negative something here. And it looks like the center point in this case, like what I'm calling that point of inflection right there, is at negative 5, negative 1. So that's what I'm going to go with as it. If you have a different interpretation, you think that's something else, that's one of the limitations of graphs, is you can't tell exactly. That's okay. I do want to move it to the right, to the left 5, so I have to do plus 5, and then minus 1. Notice that that negative, only thing it did was flip it. It doesn't change the input or the output part of that graph, like as far as the center point. Finally, D is slanted the right way. It looks like that, and I think that center point, if I was going to graph what I think it looks like here, is all the way over at 10, negative 4 would be my best guess as to what that's going to be. And if it doesn't look like 10, pay really careful attention to the scale that they have on the graph. It's counting by 4, so you do have to pay attention to that. Not flipped, so I'm going to say g of x is going to equal, to move to the right 10, x minus 10, cubed, and to move down 4, minus 4. So there's number 10. I'll skip around on a few other problems, but you can find some of the other videos linked on my webpage as well, or on the YouTube channel.